You may have noticed when we were talking about the node method that we started with the nodes, added up the currents that go into the nodes, and then proceeded. But usually in electronics, anything you can do with currents, you can do something similar with voltages to get the same place. So rather than starting with currents at a node, we can talk about voltages around a loop. And basically, instead of using Kirchhoff's current law, we'll use Kirchhoff's voltage law as our starting point for solving the system. And when we do this, we get the mesh method. It's completely equivalent to the node method, though confusions arise that often make it more difficult in practice, but occasionally it's useful. It's especially useful when we have one loop. But the first thing to do is label the mesh currents. So we have two loops in this case. This is the same circuit as the last time. We have IA and IB. And so that's the first step. In the node method, we also picked a ground node, but here we don't have a ground loop. What we do have is a loop that goes around the outside, and that's a simple loop, and it encloses the area that's outside. So in a sense, we have picked a ground mesh. The loops are called meshes. The ground one is the outside one, and we've picked it by the way we wrote down the circuit. Okay, so once we have labeled the meshes, then we label each branch. So the voltage source, voltage drop across R1, voltage drop across R2, voltage drop across I, the current source. And again, both with the directions of the currents and the directions of the voltage, it's somewhat arbitrary which way you write them down, though we will have to be careful in a second. Okay, so now for each of these meshes, we write down the KVL equation on each, and so since we have two loops, we're going to have two equations. So in this equation, I'm going to follow the arrow and go that way. So I go minus to plus on VV, so that's here, I have a plus sign, but I go plus to minus along R1. That means that whatever value V1 has, I have to put the minus sign in here because I'm going from plus to minus. It's a voltage drop in that direction. And again, I'm following the circle around. I go plus to minus along V2, and then there's nothing along the bottom, so I have VV minus to plus, V1 plus to minus, so it's a minus sign, V2 plus to minus, it's another minus sign, and that whole loop has to give me 0. Likewise here, I've drawn the loop the other direction. It's now counterclockwise. And again, I follow the arrows around. I go minus to plus through I. And so I get plus VI. That's an I, not a 1. And then I come the same direction through V2. It's plus to minus. It's a drop, so it's minus V2. The difficulty in using the mesh method is making sure to get all these signs right by very careful application of what direction I'm going around and whether I hit the pluses and minuses in the minus to plus order, in which case I have a plus sign, or plus to minus order, in which case I have a minus sign. Okay, then once we have an equation full of V's, we want to replace it with I's when we can. To do the solving, and that's where the power of both methods come in. In the node method, we replaced I's with V's. In the mesh method, we replaced V's with I's. So we go through here. VV, we know what it is. It's just V, so we don't make an I substitution there. We replace V1 with the current flowing through it, the mesh current, IA, and R1. Now for R2, we have to be more careful. Even though we're doing the IA equation, there's both an IA and an IB flowing through it, and we have to include both. So to find V2, we have to add up those currents that we're adding because they're going in the same direction, times R2. For the second loop current, we know because it's a current source exactly what it is. It can only be one thing, and that's IB. And so we just replace IB with I. Okay, so again, we have a system of two equations and two unknowns. The two unknowns are IA and IB, and we have equation A and equation B. equation B is trivial, so we just have to replace IB with I everywhere here. We do that. That's this equation. And now we pull all the i's on one side by moving both this term and this term to the right-hand side, and we get that equation, and we now can solve for IA. IA is V over R1 plus R2 minus I times R2 over R1 plus R2. We should check that the units work. Voltage over resistance gives current. Current times voltage times resistance over resistance, again, gives current. And here I've just given a summary of what we got in the two different cases, of the node method and the mesh method. Well, this is the node method for comparison with the mesh method.